part of today in Rolle's theorem is going to be just a few more examples. So we're going to look at, again, whether or not Rolle's theorem can be applied. Again, if it can't be applied, we're finished with the problem. The only way we're going to continue is if it can be applied. So in order for it to be applied, remember it has to be continuous on the closed interval, differentiable on the open interval, and f of a has to equal f of b. Well, I'm looking at this right now, and I can already see that Rolle's theorem does not apply. Before I even say why, hopefully you guys can see why. It has something to do with the bottom here, and then what interval that falls in. So Rolle's theorem does not apply because it is not continuous at x equals 0. So it has to be continuous in order for Rolle's theorem to apply. Going on to the next one, I can immediately picture in my mind that cosine of x is going to be continuous. It is also going to be differentiable. So we're just going to go ahead and state that. So f is continuous on 0 to 2 pi, closed interval, and differentiable on the open interval 0 to 2 pi. The third thing that has to hold true is that f of a has to equal f of b. So f of 0 has to be the same as f of 2 pi. So we're going to check that. What is the cosine? What is the cosine of 0? Well, the cosine of 0 is 1. And then you're also asking yourself, what's the cosine of 2 pi? Well, that's also 1. So it does hold true. Rolle's theorem does apply. So we're going to go ahead and find that c value, or those c values at which the derivative equals 0. In order to do that, we need the first derivative. So the first derivative ends up just being negative sine of x. We want to know where this equals 0. So where is the negative sine of x equals 0? So we're basically just asking ourselves, where is sine x equal to 0? Well, on the unit circle, that would be at 0, and then at pi, and then at 2 pi. Now, the 0 and the 2 pi are already parts of our endpoint. They're already our endpoints. So the c value we're looking for is when x is pi. This is our c value. It's the only one. The other two are the endpoints. Last example, we first need to show that this is continuous and differentiable. The best way to do that is just use your graphing calculator, because we're not quite sure what this looks like. So you guys can take a moment and graph that on the graphing calculator. You will see that f is continuous on 0, 1, and differentiable on the open interval 0, 1. So now we just have to show that f of a equals f of b. So f of 0, does it equal f of 1? So when you plug in 0 up here, you'd have 0 minus 0 to the 1/3, which is 0. And then when we plug 1 in, we have 1 minus 1 to the 1/3. Well, that's 1 minus 1, which is 0 also. So Rolle's theorem does apply, and now we're ready to find the c values such that f prime of c equals 0. The derivative of the function is simply 1 minus 1/3 x to the negative 2/3. We're going to set this equal to 0. So it'll be 1 minus, let's rewrite this without the negative exponent. So I'll move that to the other side. And then what I like to do is just simply cross multiply. So I end up getting 1 equals 3, the cube root of x squared. I'll divide by 3 on both sides, so I get 1/3 equals the cube root of x squared. And then in order to get x by itself, I need to cube both sides. That gives me 1/27 equals x squared, and then I'll square root it. And I'm only going to be looking at the positive portion of that because that's the only portion that fits inside of that interval. So the c value in this case is the square root of 1/27.